Good evening, everyone. I hope you are doing well, and I welcome you all in the third session of Quantum AI. Today, in this session, we are going to explore a platform which is given by IBM. So, this is going to be very new and very exciting that we have systems available where we can practice the theory or the concept we have been discussing and we have been understanding from the past two sessions. So I would quickly urge everyone to inform your friends and your mates to come up and join this live session. Meanwhile, I'll also do my part. I'll also share through my WhatsApp status so that quickly we can get more participation. As I said, today's session is going to be very interesting as this session is going to be on a platform which we can make use of for practicing, building, and creating the programs. So we were discussing about the machine learning algorithms yesterday. We just started to discuss about it. And we were discussing more on the logic gates. That is what we were discussing. We discussed it in a great length. So today what we will be doing, we will be exploring more on the platform. And once we have the walkthrough of the platform, after that, we will be again revisiting the concepts which we have discussed. And while revisiting those concepts and practically implementing them, it will be really exciting and it'll give you a joy also, because those who are having this interest on the quantum mechanics or quantum AI, you will really gain a lot out of this session. So let me quickly share my screen and let us start now. So I'll just request my teammate to help me with screen share. All right, thanks a lot. So here you can see, this is our classroom. Those who are yet to join this particular classroom, here is the classroom code. So you can see this is the classroom code. Using this classroom code, you can join in. And those who have not yet registered, so I would request you need to register in order to get the certificates, because certificates will only be provided post this workshop is over, and workshop will be over with few hands-on sessions, and we are almost on the verge of beginning our hands-on sessions. Okay, so you can bring your laptops. If you're not sitting on your laptops, you can bring your laptops, open up your laptops, and just come to this particular link, learning.quantum.ibm.com. So this link will be given to you by the team also. So I would make a request to team to share this link on the YouTube chat so that everyone can get this particular link. And I'm repeating, the link is https://learning.quantum.ibm.com. This is the link. So you can see that from 2019 specifically, there has always been a fight. Sometimes Google comes and says, we have come up with the quantum supremacy. And then they claim that our quantum computer can solve a particular mathematical problem within few seconds, and which IBM computer probably would take a few years. Then IBM comes in and says, how can you say that our computers are not so like supercomputers? Our supercomputers are not so slow. they will take just 2.5 days. So 2.5 days and few seconds, is that a very big difference? So there is a debate which keep on happening. So if you see that if a quantum computer can solve some mathematical problem in few seconds, and if a simple computer can solve that in, let's say, 2.5 days, so is this a parameter to decide supremacy? This is a question. So how would you define supremacy? So still it is very much vague. There is no clarity on it, that how to say that you have actually achieved supremacy. There's nothing yet, solid or agreed upon terms on if we can call something as supreme or not. Okay. But it's interesting to see the news, and it is interesting to always go through these concepts. I would encourage those who are watching. I know most of you are from, almost everyone is from India only. So I would encourage my Indian fellow beings to go for more awareness and to spread more awareness about not only this concept, but whatever is coming up, whatever is research area of the day. So I would really encourage you all, because there's lack of awareness, and we prefer to enter into service-based industry. Research will be done by somebody else, the product will be made by somebody else, and we will come and we will say, okay, we will do the service. So I believe that let us not just remain or limit ourselves to the service based industry. We can also come up with new R&D. We can also come up with new products. So in India, sadly, it is sad that we are not having a lot of work being displayed in terms of quantum computing also. So I would encourage that let us spread at least more awareness, and if you and I, if we are capable enough, let us try entering into such areas and come up with some products, come up with some solid R&D researches, so that we can make an impact in the society. So I hope you all must have opened up your laptops, and you must have opened this particular link, that is learning.quantum.ibm.com, and this is the home page. So here we will just do the exploration. I'll help you walk through. So you can see this is IBM Quantum Learning, and here learn basics of quantum computing and how to use IBM quantum services and systems to solve real world problems. Understand whenever there is a new tool or new platform which comes up in the market, so the primary objective of that particular new tool or that particular new project is that the community should know how to use it. If the community is not able to use the new product, then basically there's no use of that product. So therefore we get such platforms where we can explore and we can practice, so that this platform can be leveraged by industry as well. So here we have fundamentals of quantum algorithms. This is a new section they have started as a course, and if you see, we have multiple courses over here. So courses, we have basics of quantum information. It has got 4 lessons. Variational algorithm design. It has got 7 lessons. Then practical introduction to quantum safe cryptography. It has got 7 lessons again. So you can see that we have more tutorials which are coming up in future. Meet John Waters, and you can see he is Technical Director, IBM Quantum Education. So he basically helps in designing these particular labs and tools and tutorials. We also have simulators, composers, and labs which we will be using. So here you can see what kind of tools do we have. Start experimenting in one of our quantum programming environments. So we have Quantum Composer. We'll just go there. So Quantum Composer will help us to build, simulate, and run quantum circuits with a drag and drop interface. Yesterday we were having a look at different classical logic gates, and we were able to see that how the input are to be sent to the classical logic gates, and how they were coming up with an output. So very similar way here, if you see that the quantum composer is going to help us to design the circuits, design the logic gates with a drag and drop interface. So this drag and drop functionality has always been helping us to do the less coding and be very quick. Just drag and drop and you have the things set up and ready. So this is quantum composer. We will explore this interface in some time. Then we have quantum labs. So in this particular quantum lab, we can develop quantum programs in a custom Jupyter Lab environment. So the way we have Google Colab, the way we have Jupyter Lab or any other platform to start with. So we have this very similar environment like a Jupyter Lab over here, and there you can write your quantum programs. If you write the same program into your Google Colab, or if you write the same program into Jupyter, then that program is going to take hell lot of time. But if you are going to use the quantum lab, it is going to take lesser time. So that is the advantage you will be getting over here. So I hope that, yes, you must explore this quantum lab as well. So those who are very, very new and they do not know about what is a Jupyter Lab, they do not know about what is a Google Colab, I'll just show you. So here, if you see that we have a Jupyter notebook here. So you can walk through our channel, YouTube channel. You will see that where we have Python tutorials. There we have introduced Jupyter Notebook as well, Anaconda as well, and we have also introduced Google Colab. So all these things we have introduced over there. So I believe that you should go to our channel and find out the Python tutorials. There you will find initial first, second, third videos. You will find that how you can set up the Python environment and how can you install Anaconda or Jupyter Notebook, or how can you use Google Colab also. So this is, you can see this is the platform of Jupyter Notebook. This is how it looks like. And if you want to create a program, so in this interface, you need to find new. Under new, you will be able to find this Python 3, this option. So if basically you are going to click on this Python 3, then it is going to open up a new notebook. And in this particular new notebook, you can write your program. Now, if you really don't know anything in programming, if you have no idea of programming, then what can you do? In that particular case, what can you do? You can simply type in over here. Okay, I'll just tell you. You can simply type print and in bracket just type hello, hello, and just execute it. For execution, you have this button as run. So you have to write the commands in these cells and then you have to click on the run button. So this is what you can do. This is an easy way to start programming in Python. Once again, I will encourage that you can go to our channel and you can watch the basic Python tutorial and you will get a fair idea to begin with. And if you have any queries, you can feel free to write us on our channel and we will ensure that we revert you back with the help of a new tutorial. So we will always try to answer to your queries with the help of either if it is a direct thing, so we'll just answer in the comment box, or if it needs some additional efforts, so we will create a video and we will share that video with you. So this is the environment which is called as Jupyter Notebook. So I'll be closing this particular environment for now and leave this and close this, and then I'll close this particular background process as well. Another thing we have is Google Colab. So all the people who are new, I think you must be known for it. So it is basically collab.research.google.com. So collab.research.google.com. This is again very similar. Like it looks like a Jupyter Notebook only, but this is a platform given to us by Google. So here you can see I have created some of the Google Qiskit lab in Python with the help of Google Colab. Now, here you can see that we have this particular interface getting opened up, and just remember collab.research.google.com. Okay, always come back and watch these videos. Okay, by just scroll back and then you can have a look at the whatever URL I have given here. So here you can see I have installed pip install Qiskit. So this Qiskit library, this Qiskit, Qiskit library is the library which is helping us to create the quantum programs. So first I install this Qiskit library, then I import this Qiskit library, then I check the version of this Qiskit library I also basically install pip install Qiskit IBM provider. So rest I will not show you now, because like if you go ahead, I have used some of my keys given by the IBM Qiskit IBM Q provider. So this is how you can start working with collab.research.google.com. So once again, I will say, if you get any queries, just keep on writing in the comment box. We will help you. Okay. So I have introduced you that these are the options where we can work. But at the same time, if IBM is giving you the quantum lab itself, then why to go for Jupyter separately, or why to go for Google Colab separately? You are getting the lab over here, and this lab is going to get the computation done on the IBM quantum computers. So you can make use of these labs. Nevertheless, you can make use of other labs also, because you can use your API key and you can put it over there. So again, although you are writing your program in Jupyter Notebook, or you are writing your program in Google Colab, but your program is getting computed on the quantum computers of IBM, and then you will get the result. So it is one and the same thing. If you are using quantum lab, then basically you are getting all the instructions readily over there. You are getting all the interfaces where you need to put the code. If you're using any other platform, you don't have these things. So this is the only difference. Otherwise, the computation is happening in the quantum computers only. Now, other resources we have. So we have the YouTube channel. So check out the Qiskit channel lectures, tips, tricks, community updates, and more. And then we have a blog section also. Keep up with the latest developments in quantum computing. So we have a blog section where you can read more about the quantum researches which are being done. So the first IBM quantum system, one on a university campus, come to RPI. So with some university, they have collaborated probably. So now let us come back to this particular resource, which is learning.quantum.ibm.com. Now we are moving ahead. So this was the home section where we can explore multiple courses. So if you want to get started with any of the course, in that particular case, what you need to do is, just a second. Yes. So in this particular case, if you are basically getting started with any of the courses, so what you have to do, you just have to click on start course, and then it is going to basically help you start, sign in to track the progress. You need to have an account over here, or start from beginning. Anything you can basically do with. Okay, I'll help you with the courses as well. So you can start with these courses. Now after home, we have a second tab. Now, the second tab we have here is catalog. So this particular catalog, if you see, this catalog, we have explore all courses and tutorials available across IBM Quantum Learning. And the catalog again tells you here, basics of quantum information, fundamentals, the same thing is coming over here. So from home, if you see, the section of this courses is coming over here in the catalogs under courses. Then we have tutorials. So one is courses and second one is tutorials. And you can see the tutorials are here. Some of the tutorials are being scheduled. And here you can see some tutorials are there. Okay, so build repetition codes, build until success. So there are some which are basically already there. You can click on them, explore. So here you can basically get some code and all. Okay, so before entering into the code, I think you will require some more help. And for that, I'm surely there to help you to that how you can begin with. So catalog section is a quick section where you can explore all the courses. At the same time, you can explore the tutorials which are available under IBM Quantum Learning. Now we have the next section. So home, catalog, and the next section is composer. Under the composer section, this is very interesting. Here, basically, you can create your own quantum circuit. So yesterday we were making use of some handmade drawings, but we don't need now. We don't need to do that. We have everything over here. So let us do a quick walkthrough. So the walkthrough, I will show you. Create your first circuit walkthrough. So we will do this thing only as of now. So here, if you click on this, create your first circuit walkthrough, it is going to help you to design the whole circuit. So let's do this walkthrough. Okay, and I'm sure that certain things may be a little fast. So always what you can do is because you are going to get this recording, so you can always go back and pause the video and follow the steps. So here, let's build our first circuit. Composer has a customizable set of tools that allow you to build, visualize, and run quantum circuits on quantum hardware or simulators. Let's build your first circuit together, a Bell state. So we are going to create first circuit in 8 steps now. Next. So now the first step we have is, here we have operations. So you can see this is Hadamard gate. Okay, so H is a symbol of Hadamard gate. So quantum gates and operations are available over here. Gates and operations, they manipulate qubits. We now understand, like we have the classical bits, very similar way, we have qubits, and we have the representation of the qubits as ket 0 and ket 1. So that is the representation of qubits. They are the building blocks of quantum circuits. You will drag and drop operation blocks onto the wires on the right to construct your quantum circuit. So what we will do is we will pick from here and drop it on the wire. So just at the back of this particular text, we have wires. Let's see that. Yeah, so here you can have a look at it. So here if you see that we have operations and we have this Q0, Q1, and here you can see, so once you basically put your mouse cursor on certain thing, so it is a bit interactive, it is going to give you the details. So we'll construct a Bell state. A Bell state generates a particular maximally entangled 2-qubit state. So what we will do is first drag Hadamard gate and onto the first qubit wire Q0. So we are putting it over here and it says task completed. And let's do the next thing. Now the next thing is, it tells about the visualization. So here we have this Q sphere and here we have the probabilities. Now, what just happened? Visualizations use simulators to show what's happening on a quantum computer before you measure your circuit. So these are the visualizations which are going to give us an idea that what is happening inside a quantum computer. And they're updated each time you add an operation to the wire. So we have just added the Hadamard gate to the wire, and we can see there are certain changes in the visualization. Currently, the visualization shows the effect of a Hadamard gate. The qubit is now in superposition. Now let's move ahead and try to add certain more things. Now we are going to add a C0 gate. So add C0 gate to the right of the Hadamard gate. So where is the C0 gate? This is the C0 gate. So I'll pick it up and I'll be putting it on the right of the Hadamard gate on the wire Q0. So on the wire Q0, I'm doing this. This operation acts on 2 qubits, Q0 and Q1. So you can see it is acting on Q0 as well as Q1. And you can see here the output has got some changes. Notice that the visualizations update when you add new gate. The qubit is now entangled. So here you can see at back you'll be able to see the visualization is also changed. Now we will drag and drop one measurement operation. So this is the measurement operation and we'll drag and drop. This is called as C0. This is called as operation and this has to be dragged and dropped on the other side of the Hadamard, of the C0 gate. So we will be dragging and you can see on the wire Q0 and Q1. So it says about Q0 and Q1. So I have dropped it over there. The measurement result is recorded as a classical bit on the classical register. So it records the vertical wire connecting the measurement operation to the bottom wire depicts the information flowing from the qubit down to the classical register. So C2, if you see, is the classical register. Information is flowing from qubits to the classical register. So this is what it represents. Now, let us move ahead. So now is the code section over here. So this code section, if you see, in this particular code section, the code is automatically generated. The code editor updates as you add operations to your circuit. If you update the OpenQASM code, changes will be reflected in the graphical editor as well. You can see the code in OpenQASM 2.0. So this is OpenQASM 2.0. This is basically the code editor, or read-only Qiskit Python. You can export the code for use in other applications. So if you are making some gate over here, then basically you can reutilize that particular code for later. Keep learning. So not sure what to do next. So here we have a composer of docs and tutorials. You can keep on exploring it. So we just did create your first circuit walkthrough. Let's finish it up. So this is the output, this is the code we have, and these are the graphical representations we have. So composer is the section which is going to help us. So if I click on it again, so it is going to get restarted. And you can see I have not basically sign in. So if I sign in, I'll be able to run the circuit as well. Now, the next option we have is lab section. So in this particular lab section, if you see, you will have to log in with IBM ID. So if you have not yet created the IBM ID, so your today's task is to create the IBM ID. It is the same process. The way we log in into any authentic application, we need to do it with the help of either Google or GitHub or LinkedIn or any other, their partner or their authenticated partners. So we can do with that. So continue with IBM ID. I believe my IBM ID and password must be saved over here. And I don't think so they are saved. Okay, so it's asking for password. So I forgotten my password. So I'll just quickly check if I'm able to log in. So I'm just checking if I still remember my password. So it's not that particular password. So I'll have to do forgot the password. So that I'll do later. So this is the last section, which is of lab, and where we can get logged in, and we'll be able to get all the labs created over here, and we can run our programs into it. So IBM Quantum use our suite of applications to support your quantum research and development needs. So it is specifically for research and development. The platform, copy your API token, track jobs, and view quantum computer resources. So with the help of API token, we can do documentation, explore service and API documentation to start working with IBM quantum resources, and take a course, browse tutorials, and start experimenting with the Composer Lab. So these are the few pointers we have to encourage us to start working with it. And let me continue with Google, because that's an easy way to do this. So I'll just try to continue with Google, and I hope this is going to help me out. Okay, so IBM Quantum End User Agreement. So I need to accept it. So as usual, this is something I need to do. I'll just have to move this particular screen. Yes, I have moved the screen. Yes. So I accept it and accept and continue. Okay, so yeah, this is being done. Here you can see now we can explore. So this is my account, you can see, and here we have the API token. This is the API token which you can copy and or you can regenerate. So I'm regenerating the token. So now you can see I have regenerated the token. So in the Python programs which I was talking about, so this API token I need to use in order to make use of this particular platform. So here you can see up to 10 minutes per month open plan, up to 10 minutes per month, and recent jobs pending, completed jobs, one. Okay, so here 0 pending and 1. So only 1 job I have run with the help of this particular account. And so here you can see instance systems 3, simulators 5. So you can make use of them. Okay, so as of now, we can just explore, and here it'll load and show it to us. So here you can see the IBM Brisbane, IBM Osaka, and IBM Kyoto. So these are the 3: simulator stabilizer, simulator MPS, simulator extended stabilizer, and IBM Quasum simulator, and simulator state vector. So these are the available resources I have. And if I want to check all the systems, so I am just checking over here. So these are all the systems which are available, and all simulators. So these are all simulators which are available, and there are 5 only. So these are compute. So after you log in, here you can see you have a dashboard, you have compute resources, and you have jobs. So only 1 job, as I said, okay, about 2 months ago with this particular account, I had created a circuit and I had run it, and it just used it for 1 second. So as you can see, it is giving us for up to 10 minutes, because they're so quick that 10 minutes is also a good time for us to use it. And here you have again blog section where you can explore, and you will be able to get a lot about whatever new is happening. Again, this is catalog section, documentation, and yes, so composer we have seen, and labs. Yes, obviously, if I click on labs now, so we'll enter into the labs. Composer, we have seen one example, just a demo one. So your server is starting up, you will be redirected automatically when it is ready for you. And server requested. So, okay, yes. So server ready at user something something. And I'm just waiting for the server to get started and let us get some access into it. All right, so it's taking some time. Yes, so here. So this is what is started, and you can basically create some notebooks over here. You can see that you have Python 3 notebook, you have Groover's option, Python 3 notebook again. You can get the console and others also. And here we have some tutorials where you will get some program, and this instance has just got created. So with the help of these, you'll be able to work. So writing the code. So if you compare this with any of the other platforms, like we were exploring Jupyter Notebook or we were exploring the Google Colab, so it is very similar to that. So here you have the first cell, second cell, and you can keep on adding more cells. This is how you can do, and you can work along with me on these particular programs. So I hope you are able to get that this is the platform which we are going to use, and the platform name is IBM Quantum Learning. So today's agenda was to get familiar with IBM Quantum Learning platform, and the next session we will announce, and we will have the practical exposure. Excuse me. So next session onwards, we will have the practical exposure into this particular platform, and we'll try to see that how we can compose our circuit diagrams, and how can we design algorithms. That will be the next agenda, and next would be the ML parts, that how quantum machine learning and quantum AI is actually evolving, and what kind of research can be done into that. So practically we will see. Thanks a lot, everyone, for watching in, and I hope this was an informative session, and you will go through and walk through this particular platform. So do that, and that is going to give you real knowledge and excitement. Thank you very much. Thanks a lot. If you have questions, keep on writing on the comment box. We'll come back and answer. Thank you.